Hello friends, in this video we prove some results regarding the integration of the function depending on the definition of a Riemann sum. Riemann sum. The statement of the theorem or the result which is first depending on the Riemann sum is on your screen. If functions f1, f2 where f is a sum or subtraction of these two functions f1 plus minus f2 are bounded and integrable on closed interval a comma b, then integration of f is equal to integration of f1 plus minus integration of f2. Friends, to prove this, first we consider the plus and minus part is similar to the first plus one. So for epsilon greater than 0, let epsilon greater than 0 and suppose that f equal to f1 plus f2. These are the two values. Then by definition what is given? Since f1 comma f2 are bounded and integrable, as f1 f2 are bounded, f is also bounded, therefore there exists a partition p having these points x0 equal to a, x1 and xn is equal to b with norm mu of p less than delta, such that as we are applying the definition of Riemann sum, therefore summation of f1 ti into delta xi I is equal to 1 to n minus integration of f1 between the limit a to b is a less than epsilon by 2 and summation of f2 ti into delta xi minus integration of f2 between the limit a to b is also less than epsilon by 2. These functions are integrable. Now we have considered that summation f equal to f1 plus f2. So let us calculate summation of f ti into delta xi minus integration of f1 plus integration of f2 between the limit a to b, I is equal to 1 to n. Okay, this is nothing but summation of what is a f? F is a f1 ti into delta xi plus summation of f2 ti into delta xi, I varies from 1 to n, minus integration of f1 between the limit a to b minus integration of f2 between the limit a to b. Now separating the modulus property, what we get here? We get f1 of ti into delta xi minus integration of f1 a to b plus mod of summation of f2 of ti into delta xi minus integration of f2 between the limit a to b. This is less than epsilon by 2 plus epsilon by 2 equal to epsilon, and therefore the function f which is integrable, therefore integration of f between the limit a to b equal to integration of f1 plus integration of f2 between the limit a to b. f1 is Riemann integrable, f2 is Riemann integrable, and c1 c2 are constants, then c1 f1 plus c2 f2 is also Riemann integrable, and integration of c1 f1 plus c2 f2 equal to integration of c1 into integration of f1 plus c2 into integration of f2. So first we let f1 f equal to c1 f1 plus c2 f2. Therefore, Riemann sum is equal to summation of f of ti into delta xi, I is equal to 1 to n. This is nothing but C1 into summation of f1 ti into delta xi, I is equal to 1 to n, plus C2 into summation of f2 ti into delta xi, I is equal to 1 to n. This is C1 into SPF1 plus C2 into SPF2. What is given? F1 comma F2. These are the Riemann integrable over F. Therefore, for epsilon greater than 0, we can choose delta with the partition P x0 to xn such that this mu of P less than delta and SPF1 minus integration of F1 between the limit a to b is less than epsilon. We can choose, this function is integrable, so here we consider this is a epsilon divided by c1, and SPF2, this is minus integration of f2 between the limit a to b is less than epsilon divided by c2. Then mod of SPF minus this integration of f. What is the integration? Integration of, we take here c1 into f1 minus c2 into integration of f2, okay, f2 between the limit a to b dx here, dx, okay. So let it write properly. First we are now considering the Riemann sum. Mod of SPF minus c1 into integration of f1 minus c2 into integration of f2 between the limit a to b equal to, what is Riemann SPF? This is c1 SPF1 plus c2 SPF2 minus c1 integration of f1 minus c2 integration of f2, right? This is equal to this. Here we take it as a mod. If we take it as mod values, here mod of c1 into mod of SPF1 minus integration of f1, c1 is common, integration a to b, plus mod c2 into mod of SPF2 minus integration of f2 between the limit a to b. Okay, now substituting the values, upper values, here if we put upper values, we get that this is less than c1 into epsilon divided by mod c1 plus mod c2 into epsilon divided by mod c2. Okay, so let us make it as a more smaller. Since this function is an integrable, we need here epsilon, and that is why we have taken 2 here. So here this is equal to epsilon by 2 plus epsilon by 2 equal to epsilon, and that means that this mod of SPF minus c1 into integration of f1 minus c2 into integration of f2 between the limit a to b is less than and epsilon. Therefore integration of c1 f1 plus c2 f2 between the limit a to b is nothing but an c1 into integration a to b f1 plus c2 into integration f2 between the limit f is bounded and integrable on each of the interval a comma b, a comma c, c comma b, where c is a point of a comma b. Then integration of f between the limit a to b equal to integration of f between the limit a to c plus integration of f between the limit c to b. Since f is integrable, what is given? It is given that f is integrable on each of the interval a to c, c to b and a to b. Therefore, for epsilon greater than 0, there exists a partition P x0 equal to a up to xn is equal to b with norm mu of p less than delta, such that we can take this mod of summation of f of ti into delta xi minus integration a to b f dx is less than epsilon by 3. This is over integral a to b. Mod of integration f of ti delta xi minus integration a to c f dx is less than epsilon by 3. This is over integration a to interval a to c, and summation of f of ti into delta xi minus integration, this is from c to b, is a less than epsilon by 3 between the limit here c to b. But note that summation f of ti into delta xi plus summation f of ti into delta xi over a to c, a comma c and c to b equal to summation f of ti into delta xi. This is over integration a to b. Then let us calculate the modulus value of this integration. Here mod of integration a to b minus f dx minus integration a to c f dx minus integration c to b f dx equal to integration a to b f dx minus we take f of ti into delta xi over the interval a to b. Addition and subtraction of this term f of ti into delta xi integration a to b minus a to c f dx minus integration c to b f dx. This is very mechanical, we have added and subtracted. Now for one quantity we write this summation minus summation a to b over a to b f of ti into delta xi plus, for this sum we write it as a summation a to c over f of ti into delta xi plus summation over c to b f of ti into delta xi minus integration a to c f dx minus integration c to b f dx. Okay. Now separate each integral. If we separate each integral, we have already taken these values are less than epsilon by 3, epsilon by 3 and epsilon by 3. So we get this is the first bracket, the first term is less than epsilon by 3. This one and this is less than epsilon by 3, and this one and this is also less than epsilon by 3, and this is nothing but an epsilon. and therefore integration a to b f dx equal to integration a to c f dx plus integration c to b f dx. This proves the